Okay, so let's dive into all this stuff you sent me about Retrieval Augmented Generation, or RAG for short.
Yep.
It sounds kind of like something out of a sci-fi book, right?
What's really cool about RAG is it's basically about
Huh?
taking those large language models everyone's talking about.
LLMs?
Yeah, the LLMs,
Yeah.
like ChatGPT, and
Yeah.
making them even smarter.
Okay, so you sent me a bunch of stuff from Databricks. There's some Google in here, and even a breakdown of how to build a RAG system on Amazon Web Services, AWS. So you're going all in on this topic, huh?
It's a pretty fascinating topic.
So where do we even start?
Well, it seems like you're really interested in how to use your own data with these systems.
Right.
Instead of just relying on what they were trained on.
Yeah,
It's the whole core of RAG.
So we can give them access to targeted, up-to-date information.
Exactly.
Okay, now I'm intrigued.
Yeah.
Why is that so important? Aren't LLMs like ChatGPT already pretty amazing?
They are pretty impressive.
Yeah.
But they can make mistakes.
Okay.
Especially with generating information that wasn't part of their training data.
Okay.
They hallucinate sometimes, to use the technical term.
Hallucinate, so they like make things up.
Exactly. And the Databricks ebook uses a great example with Llama 2,
Yeah.
which is a powerful LLM. It was asked about something called Databricks automation building blocks. And it just completely fabricated details about what it was and what it did.
Oh, wow. So RAG steps in to prevent these AI hallucinations.
Exactly. It gives the LLMs access to relevant information,
Oh.
external information whenever they need it.
So it's like equipping them with a real-time connection to a vast,
Yeah.
ever-growing knowledge base.
Exactly.
Okay, that makes sense.
Right.
We're basically grounding their responses in real, verifiable information.
Right.
But how does this whole process actually work? Is there some super complicated algorithm?
You know, it might sound intimidating, but it's really quite simple in how it's structured. Or RAG is a four-step process: data preparation, retrieval, augmentation, and generation.
Okay, let's break down these steps one by one.
Yeah.
First up, data preparation.
Yeah.
What's happening there? Are we just feeding the LLM these PDFs and documents as is?
Well, not quite. It's more than just giving them the information.
Okay.
It's like you have to translate those documents into a language the AI can understand.
Okay.
That's essentially what we do during data prep.
Gotcha.
We break the content down into smaller chunks.
Okay.
And then we use an embedding model to convert those chunks into numerical vectors.
Embeddings, vectors, sounds like we're getting into some serious math here.
Yeah.
Can you demystify that a bit?
Yeah, it's definitely a little mathematical, but the concept is pretty straightforward.
Okay.
So think of embeddings as like compressing the meaning of a chunk of text into a set of numbers.
Okay.
And those numbers capture the essence of what that information is about.
Okay, so it's like translating a book into a different language.
Exactly.
One the AI can understand. Okay, I'm with you so far. We prepped the data, made it AI friendly.
Yep.
What's next?
That's where retrieval comes in.
Yeah.
When you ask a question,
Okay.
a special search engine steps up,
Okay.
powered by something called vector search.
Okay.
And it scans through all of those numerical vectors that we created, and it figures out which chunks are most relevant to your question.
Wow, so it's not just finding any chunk. It's about like understanding the nuances of my question.
Exactly.
And picking the most relevant ones. That's impressive.
Yeah, and this all has to happen super fast.
Of course.
Speed is crucial.
Right.
Like imagine searching through a library with millions of books to find the exact paragraph that answers your question.
Yeah.
That's essentially what the retrieval step is doing, but super fast.
Okay, this is mind-blowing. So we have the question. We have these relevant information snippets.
Yep.
Now what happens in the augmentation stage?
So this is where the real magic happens. We take those retrieved chunks and we combine them with your original question to create a supercharged prompt.
So it's like giving the AI all the right clues before it tries to answer.
That's a great way to put it. It's more than just copying and pasting.
Right.
We have to craft the augmented prompt carefully
Okay.
to make sure that the AI focuses on the most important information.
Gotcha.
There's this thing called the lost in the middle problem,
Okay.
where LLMs sometimes don't give equal attention to all parts of a long prompt.
Okay, that makes sense. It's like highlighting the key passages in a textbook.
Yeah.
Okay, so we have this supercharged prompt. What does the LLM do with it in the generation stage?
This is where the LLM takes center stage. It uses this enhanced prompt to generate a response. But this time, its response is based on the information that we've given it.
So it's like the LLM is having a conversation
Exactly.
with this data we've given it.
Exactly.
And it leads to a more accurate and insightful answer.
Right.
That's really cool. But is RAG the only way we can customize these LLMs?
It's a powerful technique.
Yeah.
But there are other methods,
Okay.
like prompt engineering and fine-tuning.
I'm curious, what are the differences?
So imagine prompt engineering as like giving the LLM really specific instructions on how to respond. It's like RGAG can change those chatbots
Okay.
to be actually helpful
Okay.
by giving them access to a company's entire knowledge base.
Yeah.
So they can give you a really specific solution.
Those are the kind of chatbots I'd actually want to talk to.
Exactly.
Any other example?
Let's say you needed to quickly find a certain clause in a really dense legal document.
Okay. Yeah.
Instead of spending hours, you could ask a RAG-powered system. What are the terms for early termination in this contract?
Yeah.
And it can pinpoint that exact clause in seconds.
Okay, that's super useful.
Yeah.
So ARGI isn't just for tech companies. It can be used in all sorts of fields.
Yeah, it has applications across tons of industries.
And it's not just about making things easier for individuals. It can change how whole organizations work.
Exactly. Think of a company with a massive amount of internal documents and research and data all locked away. RGAG could unlock all of that.
So this is starting to feel less like science fiction and more like how we'll interact with information in the future. I'm getting excited.
Right.
But let's get practical. You've mentioned these ARG systems a lot. How are they actually built? Is it something that only big tech companies can do?
Not at all. Building a RAG system is getting easier all the time.
Okay.
In fact, the articles from the Azure Architecture Center and AWS, those resources you sent, they actually give really detailed blueprints for building these systems using cloud services.
That's amazing. So what are the key building blocks?
It usually involves cloud storage, a really powerful search service, and a framework that connects everything.
Gotcha.
Cloud storage, like AWS S3, that's where we put all that chunked and embedded data.
Okay.
Then we need a strong search service, like AWS Kendra, to handle the retrieval part. And then finally, we use a framework like LangChain to make sure everything works together.
So it's like assembling this specialized team, each member with their own expertise, to create this system that's greater than the sum of its parts.
Yeah, and you don't have to be a coding expert.
Okay, good.
There are a lot of tools that make it much easier.
Okay, so we've built our RAG system. It's going, finding information, generating responses. How do we know if it's actually doing a good job?
That's a great question.
How do we evaluate its performance and ensure it's reliable?
Well, one important metric is faithfulness to the source material.
Okay.
So is the AI actually using the information we provided?
Right.
Or is it making things up again?
We want to make sure it's not hallucinating.
Exactly.
What else should we be checking?
We also need to look at how good the responses are in general.
Okay.
Are they clear, concise, and actually relevant to the questions?
Gotcha.
And of course, we need to make sure the system is responding quickly.
Of course. Yeah, nobody wants to wait forever for an answer.
Exactly.
These are all great points.
Yeah.
So it seems like evaluating these systems is a whole other science.
It can be, but there are tools that can help.
Okay, good.
And those articles you sent go into a lot of detail about all of this.
Perfect.
Yeah.
You know, we've covered a lot already.
Yeah.
And I'm starting to get this whole RAG thing. It's really fascinating.
It is.
But I'm sure our listeners are eager to learn more.
Of course.
So this seems like a good place to stop and pick up in part 2.
Yeah, sounds good.
Okay, see you there.
See you there.
Welcome back to our deep dive into Retrieval Augmented Generation.
Okay, so we laid a solid foundation in part 1.
Yeah.
But I'm ready to go deeper.
Oh.
We focused on how RAG works, how it's built. But now I'm curious about the bigger picture.
Okay.
Why is RAG such a game changer?
Well,
why should anyone who's interested in the future of AI even care about this technology?
That's a great question. It really gets to the heart of why we even want to customize these LLMs.
Right.
Like, what's the point of all this?
Well, from what I've gathered, LLMs are already pretty capable.
They can write stories, translate languages, even generate code. What's the missing piece?
Well, you're right. LLMs have come a long way, but they still have their limits.
Okay.
One of the biggest is that they're trained on these massive public data sets, which means their knowledge is basically limited to what's out there on the internet.
Okay, so they might not know my family's secret lasagna recipe.
Exactly. And that's where Argy comes in.
Okay.
It lets us go beyond that public data
Okay.
and give LLMs access to more private specialized information.
So instead of the wisdom of the crowds, we can give them access to, say, a master chef's collection of recipes.
Exactly. An LLM trained on general data might be able to tell you about lasagna,
Okay.
but a RAG system could give you incredibly detailed instructions
Wow.
from a Culinary Institute's database.
Now that's something I can get behind.
Yeah.
But it's not just about food, is it?
No, not at all.
This has implications for all sorts of fields and applications.
Absolutely.
Yeah.
Imagine a financial analyst using our RAG to look at real-time market data to create a custom investment report.
Yeah.
Or a doctor using R to look at the latest medical research and make a more informed diagnosis.
So it's like giving experts in every field a personalized AI assistant
Yes.
that can instantly process the information they need to do their jobs better.
And it goes beyond just individual efficiency.
Okay.
Already can change entire organizations.
How so?
Well, think of a company with a ton of internal documents, research reports, customer data. It's all locked away.
Yeah.
A RAG system can unlock all of that information.
Okay, so now I'm really starting to grasp the bigger picture.
Yeah.
Argy isn't just about tweaking AI, it's about changing how we access and use information as a whole.
Exactly. And it's still a relatively new technology.
Right.
We're just starting to see what it can do.
Speaking of exploring, you mentioned in part 1 that Argy can be a cheaper alternative to fine-tuning.
Right.
Can you explain that a bit more?
Yeah, so fine-tuning is basically training an LLM from scratch.
Yeah.
On a brand new data set.
Uh-huh.
This can be expensive and take a lot of time.
Right, especially with these huge models.
Exactly.
So Argy lets us use existing LLMs without retraining them.
Exactly.
So it's like upgrading your phone's software instead of getting a whole new phone.
A perfect analogy.
Okay, so Argy is making these AI tools more accessible to more people.
Right, especially people who don't have a lot of money for training models.
But are there any downsides to RJ?
That's a good question.
Are there any risks we should know about?
Yeah, I mean, no technology is perfect.
True.
One problem could be making sure the information that the RJ system finds is accurate.
Okay, yeah.
Remember, the AI is only as good as the data it gets.
Right.
So if that data is bad, the AI's responses will be bad too.
So we can't just feed it any old data.
Right.
We need to make sure it's good quality and up to date.
It's like creating a really good library for the AI to use.
Okay, so we've got to curate it.
Exactly. And that brings us to another important thing about RAG. Devaluation.
Right.
How do we know if the system's working?
Yeah, how do we measure it?
How do we know it's giving us good information?
That's a great point.
Yeah.
So we talked about evaluation in part 1, but I think we need to go deeper.
Okay.
What are some of the key metrics used to evaluate how well a RAG system is doing?
One important one is relevance.
Okay.
Are the documents it finds actually related to what the user is asking?
Right.
We also need to look at faithfulness.
Okay.
Is the AI's response actually reflecting what's in those documents?
So we need to make sure it's using the information, right?
Yes.
And not making things up.
Exactly. Then there's the quality of the responses themselves.
Okay, like what?
Things like coherence and fluency.
Okay.
Does the AI's answer make sense?
Uh-huh.
Is it easy to understand?
Right.
Is it well organized?
Yeah.
These are all things we have to think about.
So evaluating these systems is about both quantitative and qualitative stuff. We have to look at the numbers, but also just how good the responses are in general.
Exactly. It's about making sure the system is giving the user something useful.
This has been really insightful.
Yeah.
I'm starting to see how RAG isn't just a technical change.
Right.
It's a societal one, too.
Exactly.
It could change how we interact with information.
Yeah, you hit the nail on the head. Our RAG is making us rethink our whole relationship with information, technology, each other even.
Wow.
It's powerful, and we have to make sure we use it responsibly.
For sure. We have to make sure AI helps humanity.
Exactly.
This deep dive into R has been amazing.
Yeah.
I'm already wanting to learn more.
Me too. There's still so much to discuss.
Okay, well, it sounds like that's the perfect topic for part 3.
Perfect.
We'll see you there.
See you there.
All right, welcome back to our deep dive into the world of Retrieval Augmented Generation. So we explored what RAG is, why it's important.
Right.
Even touched on responsible AI. But now I want to get my hands dirty.
Yeah.
I want to see how these systems are actually built.
All right, let's do it. So in parts 1 and 2, we talked theory, big picture stuff.
Right.
Now let's get practical.
Yeah.
You actually sent some great resources
Okay.
that show real-world RAG architectures,
Okay.
even from companies like Google and Amazon.
Perfect. I'm ready to learn from the best.
All right. The Azure Architecture Center article is a great place to start.
Okay, so we're going behind the scenes at Microsoft.
Yeah, they give a really detailed blueprint for designing and developing a RAG solution
Okay.
using Azure, their cloud platform.
I'm all ears.
Okay, so they really emphasize a structured approach.
Uh-huh.
It all starts with a preparation phase
Okay.
where you define your goals,
Okay.
you gather some sample documents,
Uh-huh.
and you come up with some test queries.
So before we write any code,
Yes.
we need to know what we're trying to do.
Exactly.
And what information the system's going to work with.
It's like an architect drawing up blueprints
Okay, yeah.
before building a house. Got to plan it out.
Gotcha.
Once we've got that done, we move on to chunking.
Right? Chunking. Break down those big documents
Yeah, exactly.
into smaller pieces that AI can handle.
The Azure article actually talks about several different ways to do chunking.
Okay.
We might just split by sentences
Uh-huh.
or use fancier techniques
Okay.
like custom splitting,
Okay.
or even use language models to help.
So choosing the right chunking method really depends on
Right.
what kind of documents we're using and what we're trying to achieve.
Exactly. No one right answer.
Okay.
It's all about using the right tool for the job.
Makes sense.
After chunking, we do chunk enrichment.
Okay, chunk enrichment.
Yeah, it's where we clean up those chunks,
Uh-huh.
get rid of variations that don't matter,
Okay.
and we add valuable metadata.
Metadata, is that like adding tags or labels to the chunks?
Yeah, exactly.
Okay.
So things like titles, summaries, keywords,
Okay.
even information about where the chunk came from.
So it's like giving the AI a set of cliff notes
That's a great way to put it.
to help it understand better.
The Azure article talks about a bunch of tools for generating metadata.
Okay, cool. So after enrichment
Yeah,
comes the embedding phase.
that's right.
I think we talked about this before.
You did?
Those numerical representations of text
Uh-huh.
that help the AI understand meaning.
Exactly. This step involves choosing the right embedding model
Okay.
for our task and using it to turn those enriched chunks
Okay.
into vectors.
You mentioned before that choosing the right embedding model
Yes.
is really important for the whole system.
Absolutely. Different models are good at different things.
Yeah.
Like, you wouldn't put a motorcycle engine in a truck.
Right.
Got to choose the right tool.
Great analogy.
Okay, so we've got our chunks.
Yeah.
We've enriched them.
Uh-huh.
We've embedded them.
Yeah.
Now what happens to all those vectors?
Yeah. Where do they go?
That's where search indexes and vector databases come in.
Oh.
This is where we create that huge searchable database
What?
for the AI.
So it's like building a giant specialized library
Just
just
like
for the
you-
AI.
The Azure article really stresses how important it is to set up these vector databases properly
Okay.
so the AI can search quickly and accurately.
So there's a lot of work behind the scenes
There is.
to make this search stuff work well.
Yeah, and it's not just about vector search.
Okay.
The article talks about other options too.
Like what?
Full text search,
Okay.
hybrid search,
Yeah.
even combining different searches manually.
So we have a whole bunch of tools to choose from.
Yeah, and using the right combo depends on the data and the situation.
Okay, so we've got retrieval working.
Yeah.
But how do we actually test it?
That's where retrieval evaluation comes in.
Okay.
So we run a bunch of test queries
Mm-hmm.
and we analyze the results.
Okay.
We use specific metrics to measure how accurate and relevant the results are.
So we're putting the system through its paces
Exactly.
to make sure it can handle anything.
And we don't just evaluate once.
Right.
We keep monitoring and refining things
Yeah, okay.
as our data changes and our needs change.
So this Azure architecture,
Yeah.
is this how everyone's doing ours?
Well, each company has its own tools,
Yeah.
but the core ideas are pretty much the same.
Okay, so whether we're talking Azure,
Mhm.
Google Cloud,
Yeah.
or AWS,
Right.
the
Mm.
basic building blocks are consistent.
Pretty much.
So what about Google and Amazon? What
Yeah.
are they doing?
So Google really highlights its Vertex AI platform
Okay.
as a key part of building our edge solutions.
Uh-huh.
Their approach is all about using their knowledge graph and search capabilities
Right.
to help the AI understand things better.
So it's like giving the AI Google search,
Exactly.
but even better.
On steroids.
Yeah.
Amazon's approach is really modular.
Okay. In what way?
They like to combine different services.
Okay.
Like AWS Kendra for search,
Mm-hmm.
AWS S3 for storage,
Okay.
and Amazon Bedrock for their foundational models.
So give you the pieces,
Right.
and you can put them together however you want.
Exactly. They also like using frameworks like LangChain to manage all the different parts.
It's so interesting to see these big companies tackling the same problem in different ways. But it seems like the basic principles are the same no matter what.
That's right. And that's the great thing about this field.
Yeah.
The technology's changing fast, but the core ideas are becoming standardized.
This whole deep dive has been an incredible journey.
Yes, it has.
We started with just the definition of RAG, and now we've gone behind the scenes to see how these things are built.
I'm glad you feel like you've learned a lot.
I really have. What about our listeners?
Yeah.
I bet they're full of ideas now.
I hope so.
About how to use RAG in their own work.
Blog is ripe for innovation. I can't wait to see what people build.
To everyone listening, go check out the resources we've mentioned.
Yes.
They're full of great information.
They are.
And remember, learning never stops.
Never.
Keep asking questions, keep exploring, keep pushing the boundaries.
That's the spirit.
Thanks for joining us
It was a pleasure.
on this deep dive into Retrieval Augmented Generation.
Yes, thank you.
Keep learning, keep innovating, and keep diving deep.
See you next time.